Measurement of machine learning models. So there are various ways to measure the performance of machine learning models. One simple way to measure the performance of the machine learning model is accuracy. So we'll discuss accuracy here. So accuracy is equal to number of correct predictions divided by total number of data points, total number of data points in test data set. Because we use test data set to measure the performance or to test the performance of the model. So let us say we have 100 data points in our test data set, and out of 100 data points, let's say 60 are positive. 60 data points belong to positive class, and 40 belongs to negative class. So we have only two classes. So 60 belongs to positive class and 40 belongs to negative class. So out of 60, when I run my model on this data set, out of 60, let's say 55 are correctly predicted by the model, correctly predicted by our machine learning model. And out of 40 negative classes, let's say 35 are correctly predicted by our model. So in total, there are 90 correct predictions, 55 positive correct predictions. So out of 60, 55 positive correct predictions, and let's say 5 were wrong predictions. So in total, we have 90 correct predictions. So therefore, the accuracy of the model, is equal to 90 are the correct prediction divided by 100. 100 are total data points, which is equal to 90%. So that is how we compute the accuracy of the model. So accuracy is a very simple measure, but it has certain drawbacks. So let's see the drawbacks of this model, this measure accuracy, drawbacks of accuracy. So let us say we have this data set in which we have out of 100% data points, let's say 90% are belonging to positive class and 10% are belonging to negative class. Let's say 10% are belonging to negative class. And let's say we built a very simple model, machine learning model, which simply returns our machine learning model simply returns positive for any data point you give it to the machine learning model. It will return positive. That data point will be classified as positive by our machine learning model. Any data point you give it to our model, it will simply classify it to be positive. Now if we run this model on our data set, this is our test data set, right? Yeah, which is imbalanced, right? Which you can see is imbalanced data set, right? But if you run this machine learning model on this data set, it will return us an accuracy of 90%, right? Because for 90% of the data points, it will classify it to be positive, right? So out of out of this 100% data points, it will classify 90% correctly, because 90% are positive points here. So if you throw those 100% data points on this model, it will return you positive in 90% positive 90% of the time. And even that for 10% also it will return positive, but that will be misclassification, but still will get an accuracy of 90%, right? So that is the drawback of this accuracy measure when the data set is imbalanced data set. So accuracy does not work with imbalanced data set. That is one drawback. There is one more drawback. Let us say we have this data set, like we have here x and y, right? So let's say x data points are x1, x2, x3, and x4. Now let's say y, our model is returning the probability score, or the classes of this point are, let's say x1 class is, let's say 1, x2 class is 1, x3 class is, let's say 1, and x4 class is 0. Let's take one more data point x5 whose class is 0, right? Now we have a model which returns the probability score. Now when I give this data points as input to the model, it will return the probability score, right? As a as classification, right? Let's say the score written by the model is, for x1 it returns 0.95, let's say. For x2 it returns 0.85, and for x3 it returns let's say 0.75, and for x4 it returns, let's say 0.20, and x5 it returns 0.10, right? So we have this model which returns the probability score. We have, let's say we have model 1, model 1 which returns this probability score, and let's say we have one more model, machine learning model 2, which will return this score. Let's say this is, let's say 0.8, this is 0.7, let's say this is 0.55, this is 0.47, and this is 0.45, let's say, right? Okay, now if you see, these are the scores written by these two models. Now if we approximate these scores in order to compute the accuracy, let's say, so the class of model classes written by model 1 will be y1 y1 hat, let's say, will be this 0.95 is close to 1, so this will be approximated to 1. Similarly, this will be approximated to 1. This will also be approximated to 1. This will also be approximated. This will be approximated to 0, and this will be approximated to 0 because it's less than 5, 0.5, less than 0.5, right? So now similarly we have y2 hat, that is the classification done by model 2. We will convert these scores into the classes. So this is 0.8, which is greater than 0.5, so it will belong to class 1. So 0.7 is again closer to 1, so it will be 1. So 0.55 is 1, and again this 0.47 is less than 0.5, so it will be 0, so it will be 0. Now if we compute the accuracy of this model 1 and model 2, the accuracy are nearly same, because for see the classes we got by model 1 and model 2 are same. We got the same output. That means the accuracy of model 1 and model 2 is same. So how will we compare these two models, right? Which one is best? Now you can see, if we, from the score, we can come to know that model 1 is doing fairly good, right, compared to model 2, because model 2 scores are less or not very accurate compared to model 1. So that's why by looking at the score we can come to know that model 1 is better than model 2, but by looking at the classes we cannot, or by looking at the accuracy score which we can get by this, by using this classes, right? We can get the accuracy score by using this classes. So accuracy score is same for model 1 and model 2, so we cannot determine by looking at the accuracy score which model is better. So that is one more drawback of this accuracy. So accuracy does not work well, or it is not useful when the data set is imbalanced, and when the scores are probability scores, like probability scores. So we'll see another measure or other measures in the other video. So thanks for watching.